Hello students, in today's video we'll discuss the preparation of alcohols from carbonyl compound. So let us understand what do you mean by carbonyl compound here. So if you are having carbon bonded to double bond oxygen, that is C double bond O, the carbon in this compound is called as carbonyl carbon and oxygen carbonyl oxygen, and C double bond O is called as a carbonyl group. The compound which are having this C double bond O in them, we call them as carbonyl compound or carbonyl, since C double bond is a carbonyl group present into them. So let us recall here. So if your carbonyl carbon is bonded to one side by alkyl group and another side by hydrogen, it is called as an aldehyde. Similarly, if your carbonyl carbon is bonded to one side by alkyl group and another side by also an alkyl group, we call it as ketone. Then next, similarly, we'll consider carbonyl carbon. On one side it is bonded to alkyl group and another side by OH. So you call it as an carboxylic acid. Next, if you consider an carbonyl compound, that is C double bond O, if on one side it is attached to an alkyl group and another side by alkoxy group, it is called as ester. These are the names of the functional group that are formed. And then if at all your alkyl group is bonded to carbonyl carbon on one side and halide on one side, it is called as acyl halide. Similarly, if the carbonyl carbon is bonded on one side to an alkyl group and on another side to NH2, we call it as an amide group. So these are the different carbonyl carbon compounds. So what is common in all these compounds? So you can see C double bond O, that is carbonyl group in aldehyde, carbonyl group in ketone, as well as in carboxylic acid. In other examples also carbonyl group in ester, carbonyl group in acyl halide, as well as carbonyl group in amides. So what we commonly call these compounds as, these compounds are called as carbonyl compounds, but specifically we classify them into aldehyde and ketone, carboxylic acid, ester, etc. when and group, that is like hydrogen, if it is attached to C double bond OH and alkyl group, it is called as an aldehyde. Similarly, if two alkyl groups are attached to carbonyl carbon, it is called ketone. If R and OH, carboxylic acid. If R and OR, it is ester. If R and Cl, it is acyl halide. If R and NH2, it is an amide. But what is common here? NH2 is common. C double bond O is common here. Next, consider reduction of aldehyde and ketones. So here aldehyde, in the carbonyl compound we are selecting only aldehyde and ketone. So we'll consider the reduction of aldehyde. So as you have studied in earlier classes, reduction refers to what? Either it refers to removal of oxygen, or even you can call it as what? Addition of hydrogen. So in this reaction we'll see that instead of removal of oxygen, we see that addition of hydrogen will take place. So what we are saying, reduction may occur either by removal of oxygen or it may occur either by addition of hydrogen. So in this reaction we'll see that addition can get added to the aldehyde. So how this hydrogen will be getting added to the aldehyde, we'll see. So to understand that, you have to know the nature of the carbonyl group. So addition of hydrogen to aldehyde, we'll see the nature of the carbonyl group first and then show the addition. So you are having R, then C double bond O and H. So here we are saying that hydrogen is getting added here, and RCHO is nothing but which it is an aldehydic group. So we have selected aldehydic group. Since due to the electronegativity difference, carbon will be partially positive charge, oxygen partially negative charge. So oxygen will give its electron pair to hydrogen. The hydrogen pair shifts to the another hydrogen, it comes and bond to the partially positively charged carbon. So the product obtained here will be R. C had already one H, so it gets another H, it becomes a CH2. C was doubly bonded, the electron pair, since carbon can form 4 bonds, we have shown the 4 bond. The double bond shifts to oxygen, making it completely negative charge, and that electron pair is given to hydrogen and forms a bond OH. So it is formed as a product here. Alcohols are formed as product. So when aldehyde reacts with hydrogen in the presence of palladium catalyst, it is forming alcohol, and since OH is attached to primary carbon atom, we call it as an primary alcohol. Consider an example here. So if aldehyde, that is CH3CHO, is made to react with hydrogen, let us recall the structure here. CH3, C double bond O, it is bonded to H. We know that carbon is partially positively charged, oxygen partially negatively charged. Hydrogen, a molecule we are having, and the addition takes place in the presence of palladium catalyst. One of the hydrogen is taken by oxygen and one of the hydrogen by carbon atom. So we'll show that one of the hydrogen reacting with the carbon atom by the shift of electron pair. Electron pair from the double bond shifts to oxygen, and oxygen gives its electron pair to hydrogen. So what will be the compound form? CH3 as it is. Next you are having a carbon which already had one hydrogen. Another hydrogen is getting attached to it. So totally two hydrogen. It becomes a CH2. It was doubly bonded. One electron pair is shifted on oxygen. It becomes a singly bonded. It was having oxygen attached to it and oxygen giving its electron pair to hydrogen. So the product formed here is CH3CH2OH, and the product here obtained is an alcohol. So what do we say here? The product obtained, one of the carbon atom takes what? One hydrogen, and one of the oxygen atom takes one hydrogen, and since this OH is attached to the carbon which is surrounded only by one carbon atom, it is called as a primary alcohol. Let us consider another example. Here I have taken an example of propanol. So try to write the product for it, try to solve it, and remember always, whether it is any kind of aldehyde, on hydrogenation it always provides or it always produces primary alcohol. So remember, note it, it is important for your theory as well as for your CET NEET exam, that aldehydes on reduction always form primary alcohol. Reduction in what ways we are studying here? Reduction by the addition of hydrogen. So note it down. Next is reduction of ketones. So here reduction of ketones, the another carbonyl compound which we have selected is an ketone. We know that here carbon is partially positively charged, oxygen will be partially negatively charged. We are showing the addition of hydrogen here. One of the hydrogen gets added to carbon and another hydrogen gets added to another oxygen, and what do we obtain here? The product obtained here will be R as it is. There was only carbon having one alkyl group. To that it was doubly bonded oxygen, it becomes single bond. To it is having only one alkyl group, one hydrogen gets attached to it, and on the other side other alkyl group, and here you are having O forms a bond with H, so we obtain an alcohol. Now this is a carbon which is surrounded by two alkyl group or two carbon atom, hence it is a secondary carbon, and since OH is attached to secondary carbon atom, it is called as an secondary alcohol. Okay, let us substitute this R group. Instead of R, we'll take methyl group. So here we get it as CH3C double bond O CH3. It is also called as acetone or propanone. Carbon is partially positive charge, oxygen partially negative charge. One of the hydrogen goes with carbon, another hydrogen goes with oxygen. Remember this, we are adding hydrogen here, reduction in terms of addition of hydrogen. So CH3 as it is. Next you are having a carbon which accepts one hydrogen, so it becomes a CH, and it is bonded to double bond oxygen. It becomes a single bond O, and oxygen accepts hydrogen atom, so it becomes OH, and finally you are having CH3. Now the carbon to which OH is attached is surrounded by two different carbon atoms, hence it is secondary carbon, and since OH is attached to secondary carbon, it is called as an secondary alcohol. See, you can carry out the reduction process here and you obtain an secondary alcohol here, and the name of the product here is propan-2-ol. So reduction is carried out in terms of addition of hydrogen. There is another method. One was addition of hydrogen in the presence of catalyst. Second is by the addition of NaBH4. So we are saying that reduction is occurring in the form of what? Addition of hydrogen. So NaBH4 helps in the reduction by helping to add an hydrogen. So we say that reduction is taking place by addition of hydrogen. So what is NaBH4 providing? That is sodium boron hydride. It is providing hydrogen. We know that carbon is partially positive charge, oxygen partially negative charge. One of the hydrogen is taken by carbon and another hydrogen is taken by oxygen. So the product obtained here will be CH3, CH, to that OH is attached and again CH3. Same kind of product, just what you have shown different here is H2 and NaBH4. So try solving this example and drop it into the comment section. What is your answer? So CH3, CH2, C double bond O, CH3. It is carrying out reduction in the presence of NaBH4. I hope it is clear to you. So what we say here now, noted that we have compared aldehyde. Aldehyde forms primary alcohol. Now ketones will always form secondary alcohol on reduction, that is by addition of hydrogen. So whenever ketones undergo reduction, ketones always form secondary alcohol. So this is a conclusion what we draw from the given reactions. Ketones on reduction form secondary alcohol and it is important for your CT. Consider the next method by reduction of carboxylic acids and esters. Carboxylic acids and esters both are carbonyl compounds. So let us write the formula of these carbonyl compounds. Carboxylic acids are represented as RC double bond OOH, whereas esters are represented as RC double bond OOR. So let us see the reaction here. We'll consider carboxylic acid here. So when the carboxylic acid is made to react with lithium aluminium hydride, we obtain alcohol. Now what is the work of lithium aluminium hydride? Lithium aluminium hydride helps to carry out the reduction process. What we had studied in the first one, that is of aldehyde and ketone, addition of hydrogen was taking place, whereas in this case of carboxylic acid, along with addition of hydrogen, removal of oxygen will be taking place, indicating that the reduction is carried out in both the ways. Oxygen is removed and hydrogen is added. Now we require OH group to form an alcohol, so we will not do anything to this OH group, it remains as it is. Only the oxygen which is present on the carbonyl carbon should be replaced by what? Hydrogen. So we say that removal of oxygen is taking place and addition of hydrogen. It is easy to remember that whenever lithium aluminium hydride is taken, since it contains hydride, addition of hydrogen takes place and one oxygen can replace two hydrogen atom. So we are replacing one oxygen by two hydrogen atom and it was bonded to OH, will retain as it is. So what is a product formed here? Alcohol is a product formed. Let us consider now in what way this lithium aluminium hydride is reacting. You can see it is having 4 hydrogen atoms, so I'll consider those 4 hydrogen atoms. Now we say that oxygen is replaced by hydrogen. How many hydrogens are required to replace? 2, and remaining that oxygen will react with the remaining 2 hydrogen atom, form water. So the product obtained here will be RCH2OH and the product obtained is an alcohol. Usually, we don't carry out the reduction of carboxylic acid directly by making use of lithium aluminium hydride because it is an expensive reagent. Just to in smaller quantities, if we are extracting, we avoid making use of lithium aluminium hydride. In what is the other way to obtain the alcohol? We'll consider now. We'll convert it into ester now. Our carboxylic acids are converted into esters and esters on hydrogenation will give you the corresponding alcohol. So carboxylic acids are made to react with an alcohol in the presence of acidic condition. It results in the formation of ester and this is already what you have studied in your 10th standard called as esterification reaction. So the product obtained here is an ester. Why we call it as an ester? Because it has the formula RC double bond OOR dash. Now let us consider that addition of hydrogen takes place, that is hydrogenation of the ester. See, we are not balancing the equation. Remember here I am not balancing. I am just telling you what is the possible product formed. So hydrogen will get added here. hydrogen will get added in such a way that one of the hydrogen will go to the alkoxy group, that is to oxygen H gets attached and it forms the alcohol, and another hydrogen atom, two hydrogen will go to the carbon atom and one of the hydrogen to the oxygen atom. So the product obtained here is RCH2OH. So we obtain a mixture of two different alcohol, but you can clearly see one of the alcohol is the one which we have already used in our first step, that is conversion of carboxylic acid to ester. We obtain that alcohol as it is. So here what we see, addition of hydrogen takes place to alkoxy group and carbonyl carbon and oxygen. Let us consider an example. Take an example of acetic acid and methanol. So we'll consider CH3COOH reacting with CH3OH in the presence of acidic condition. Remember, whenever carboxylic acid react with alcohol in the presence of acidic condition, it forms ester. So here we are saying that H2O is removed. In acidic condition, H2O will be removed, resulting in the formation of ester. So what is the formula of the ester we are obtaining here? It is CH3COOCH3. So whenever you are having COOCH3, it indicates what? It is nothing but an ester. So let us split the structure and write. Let us represent the carbonyl group here, CH3, C double bond OOCH3. Now in the presence of hydrogen, that is due to the addition of hydrogen, it will break down into two components. We'll write that components here. One is your alkoxy group and another is your carbonyl group, or we'll see that here carbonyl carbon acquires a positive charge and alkoxy group negative charge. One of the hydrogen gets associated to alkoxy group and another hydrogens, that is 2 to the carbonyl carbon and 1 to the carbonyl oxygen. So the product obtained here will be CH3. The carbon will have two hydrogen atom and it will form CH2. It was bonded to oxygen OH plus of CH3OH. So CH3OH was the alcohol which we had used in the first step, and this is a process which is used to carry out the reduction of carboxylic acid. I hope you found this video useful. Thank you for watching. Please like, share and subscribe.